Welcome to another video on our YouTube channel. In this video I will talk you through the solutions to exercise 3.2, so the second exercise on our third assignment on the topics of dynamic efficiency. In this exercise we are asked to consider a duopolistic market for a homogeneous good. We know that the demand function is defined as follows, so quantity as a function of price equals 1680 minus 4p. Okay, so let's start with task A. Task A really serves as it says, as a benchmark situation. So this is just our point of comparison for the upcoming exercises, or tasks rather, within this exercise. So this really is a repetition of Cournot and Bertrand competition models, which we already discussed on the previous assignment. So I will go through this rather quickly. In case anything is unclear, I would refer you to the solutions to assignment number 2, where we are talking about Bertrand competition and Cournot competition in greater detail. Alright, so benchmark definition is defined as follows. We have two symmetric firms. Both firms have costs, constant marginal costs of C0 equal to 9. And then we are asked to derive the market equilibrium for both Cournot as well as Bertrand competition respectively. Okay, so let's start with the profit maximization in a Cournot competition. Of course, as you already know, first step is, as always, to state the profit maximization problem. And in this case, because we have symmetry of firms, we can state it with an index I. It's the same profit maximization problem for each firm I, where of course I takes values 1 and 2. And the same is true for J, but technically I equals unequal J, right? Right, just to be really specific, but yeah. So how do we find the market equilibrium then going forward from this profit maximization or from this maximization problem? Well, we find the first order derivative, or we find the first order condition of this market equilibrium of this profit maximum in the more immediate sense by calculating the first order derivative of the profit of firm I with respect to the quantity of firm I. And from this we can then state the reaction function of firm I. Okay. Right. So from this reaction function for any firm I, we know that by symmetry it's the same for both firms, of course. So we can now find the profit maximizing quantity Qi as a function of all other market parameters, which are all, of course, given in this exercise. So for a constant marginal cost C0 equal of 9, we know that the quantity each firm produces in the market equilibrium equals 548, which results in a market equilibrium price of 146. With this quantity and price in equilibrium, we can then calculate the profits of both firms, or of each firm respectively, rather, to be more precise, simply by using this quantity and this price. And then we know that each firm has a profit of 75,076. All right. Onto the Bertrand competition. And as we discovered last week, Bertrand competition, or finding the market equilibrium in a classic, or in this version of the Bertrand competition, is really easy, because we know that the price will take the value of the marginal costs. So the price in the market will be equal to C0, of course, there's an index missing, equal to 9. And for this costs, we know that each firm will produce 822 units of this good, and the profits of both firms will be 0. All right. Now that we have found this benchmark situation, let's move on and deal with the more interesting stuff. Namely, let's now consider a situation where we're no longer in this symmetric world. Okay, so we are now asked to assume that both firms are in Cournot competition and that only one firm can invest into a new production technology. This technology reduces production costs to C1 equals 6 per unit for exactly one period. Alright, so just imagine a situation where now in this bedrock competition, one and only one firm can invest into a technology and by doing so reduce their own production costs. Okay, so the rest of the task we will discuss later. So let's first have a look at how we would approach the situation. How would we find a market equilibrium in this situation? Because as I already said in the beginning, we are no longer in a world with symmetric firms. For the first time for this lecture actually, or for this course actually. So in this situation, let's just assume that firm I, without any loss of generality, let's just assume firm I is the one that cannot invest and firm J is the one that can invest. So for firm I, the profit function of course does not change at all, because firm I is still faced with the same marginal costs C0 and it's still the exact same profit maximization problem which we already discussed in the benchmark situation. Firm J, however, now is slightly changed, because we have to be very mindful that we now consider that firm J, after investment, would have marginal costs of C1, so the now reduced marginal costs. Okay. Apart from that, of course, the strategy is exactly the same. So we state the profit function, which now depends on C1 and not C0. We state the first order condition of the profit maximum, use this first order condition to find the reaction function of the firm, and and then we are already almost there. Okay, so now we know both of the reaction function of the firms. Firm I's reaction function, of course, still depends on C0. Meanwhile, firm J's reaction function, of course, depends on C1. All right. The next step in the solution of this task is to find the market equilibrium actually. So we know both of the reaction functions, so we can of course immediately substitute C0 with 9 and C1 with 6 and then just solve for the market equilibrium using one parameter less. We decided in this solution to stick with the parameters just to get a little better understanding on what actually happens and where the differences come from. So it's just a nice exercise, I would guess. I would say. Yeah, but you can absolutely immediately substitute C0 for 9 and C1 for 6 and just run the numbers instead of the parameters. Aside from this, finding the market equilibrium is of course done in the exact same way in which we did it previously, right? So we stated the reaction functions of both firms on this slide. So using these reaction functions, we can now substitute them into another, find the intersection of this reaction function, and by doing so, we will find out that firm I has a market equilibrium quantity of 544 and firm J has a market equilibrium quantity of 556. So noticeably, the firm without investment now has an equilibrium quantity that is lower than the one of the firm with investment, right? The price, of course, is the same for both firms. That's just how this model functions. That's just how this model is assumed to function. So this is the individually produced quantities of the firms, and using these individually produced quantities, we can then, of course, by having a look at the demand function, find out what the equilibrium price in the market would be in the situation, namely 145. Knowing quantities and prices, we can then, of course, calculate the individual profits. Again, keeping in mind that when calculating the profits of firm I, we have to consider that firm I still has the old high marginal cost of 9. unlike firm J, who has the new lower marginal costs of 6, C1. Okay, so the profits of firm I then are 73,984 and the profits of firm J are 77,284. All right, then to the last and final step of this task B, what is the maximum any firm would be willing to pay for this new technology? And in this case, we need to consider two different subcases. First, only one firm has access to the investment into the new technology, and second, the investment to the new technology is available to both firms. And this, I realize this can be a little confusing at first, why this implies two actually different cases, but we will go through this solution step by step, and in doing so, I hope it will be clear what exactly we mean by this. Okay, so what is the willingness to pay of a firm for a new technology, like conceptually, or in how do we understand it in the context of this exercise? Well, if the new technology increases the firm's profits, then the firm should be willing to pay this increment in profits, right? Because it is better off, or it is at least not worse off by employing the new technology if the new technology costs weekly less than the increment in profits. That's the argument. So, in order to find the willingness to pay, we look at the difference in profits of the firm that is driven by this investment into the new technology. Okay, and as previously, we still assume that firm J is the one that is investing into the new technology. Let's consider the first subcase, where the innovation is accessible only to the investing firm. Okay, so firm J is now the one and only firm that may or may not invest into this new technology. Firm I simply does not have this choice. Okay, so what firm J needs to compare then is a situation, let's start over here, like the benchmark situation, where both firm I and firm J work using the old higher marginal cost C0. This old world is now compared to the new situation where firm I is still operating with the old larger marginal cost, but firm J now, because they invested, can rely on C1, so the lower marginal costs. Okay? So when calculating this difference in profits, we are comparing these two states of the world. State of the world where no firm has the new technology, compared to a state of the world where only firm J has this new technology. Alright, then we calculate the profits simply by looking at the results of the previous slides, right? So we already know the profit function for all of these situations, and we can then calculate that the change in profit of this firm J, of the investing firm, would be 2,208. Now to the second case. In the second case, the investment into the new technology is available to both firms. So firm I can invest into the new technology, or firm J can invest into the new technology. And that is what is reflected in this comparison up here. So we are still comparing the situation where firm J has invested and is now operating under the new lower marginal costs. Meanwhile, firm I still has the high and old marginal cost C0. But the version with which we will need to compare this is an alternative world in which firm J did not invest, but firm I did invest. Okay? Because in this case, by assumption, firm I is at least able to invest. And if we do this, we will find out that, because the comparison situation, so to speak, is getting worse for firm J, the increment in profits by choosing to be the one firm that invests and not the firm that has not invested, the profit increment is larger than in the first case, namely 3,300. Okay, now the bottom line of this is that competition, namely in this case competition concerning the access to this technology, increases the willingness to pay for the new technology. All right, now to task C. We are asked to continue to assume that at most one firm can employ the new technology. So we are back again to the first case. We are then asked to calculate what is the willingness to pay for such a technology in case of Bertrand competition. And at this point we really have to think about what is happening in Bertrand competition, what are the strategies of each players, or we simply have to remember what we discussed last week in assignment 2, because that is exactly what we were going through assignment 2 in last week. All right, so as a quick recap of the idea behind Bertrand competition and the strategies in Bertrand competition, well, the strategy in Bertrand competition for both firms or for all firms is to undercut your competition, your competitors ever so slightly, and by doing so, of course, drawing the whole demand onto yourself. So, investing into this new technology and thereby reducing your marginal costs below 9 and below the level of all competitors, that is, of course, gives you the opportunity to undercut all the competitors. Because in the equilibrium, as we saw in task A, all firms are asking for the same price in market equilibrium, which is exactly their marginal costs. Now, if there's one single firm that, due to an investment, is now able to produce at lower costs, that of course means that they can unilaterally decrease the price ever so slightly by some marginal amount epsilon, and thereby serve the whole market. Okay, that's the whole idea. Now, of course, we need again to take a step back and think very carefully of what might happen in the market. When we were talking about Bertrand competition last week, we were considering a best response function, a reaction function that was defined in 3 steps, right? And most notably, what we now have to keep in mind is that there's this one step of the reaction function where it's actually profit maximizing to set the monopolist's price. So what we will have to consider in order to find the optimal pricing is whether or not it is profit maximizing to choose the monopolist price, or if it's profit maximizing to undercut ever so slightly and choose or set basically C0 minus epsilon. Okay? So let's consider the first case, because it's maybe the more intuitive case. In this situation, if it was profitable to undercut ever so slightly and not set the monopolist price, we're talking about so-called non-drastic innovations. So the profit in this case then is calculated as the profit margin, so the difference between the market price and the marginal quantity of the innovating firm times the quantity they sell on the market, and the quantity they sell on the market, of course, then can calculate it by simply plugging this price, this market price, into the demand function, which is given in this exercise. And so we get the result of profits of the innovating firm of 4,932. All right, so this results then that the innovating firm that now is able to undercut its competitors no longer has 0 profits. Okay, And by the same logic which we applied earlier, the maximum willingness to pay for this technology then equals the gain in profits, so in this scenario 4,932 as well. All right. Now to the second case. And again, for this second case, we need to remind ourselves that the best response in the benchmark competition really depends on where in the price interval we are right now. And as a reminder, again, I would like to refer you to last week's exercise, last week's assignment videos, where we were talking about the best response and the best response functions of both firms in benchmark competition in great detail. So I would like to refer you to this video. In particular, what we are looking for, just as a sketch, is, well, consider a world where the new marginal costs that the firm achieves by innovating is below the profit maximizing price of the monopolist, PM, which in turn is below the previously incurred marginal cost, C0. So the monopolist price before was simply not feasible to any firm. But now, after the innovation, it actually is possible for the innovating firm at least to now set the monopolist price. And that, of course, in this world, if this statement is true, then of course setting the monopolist price would be profit maximizing instead of actually slightly undercutting the competitor's C0. Okay? If this is true, if we actually are in this kind of world, then we are talking about a drastic innovation, where the new market price equals the monopolist's price. All right. So, how can we find out whether or not we are facing case 1 or case 2? Well, one quite simple way and quite quick way to find out whether or not we are in case 2 is by having a look at the monopolist's price. Because we know C1, it equals 6, and we know C0, it equals 9. Now let's find the monopolist's price, right? Simply by finding out what is the profit maximizing price of the monopolists. And in case you need a quick reminder on how to do this, I would like to refer you to the videos on assignment 1, where we did this profit maximization problem in monopolies. And if we do so, in this specific case, we'll find out that the monopolist price equals 213, which of course is not within this interval. So this is not true. We are not in the second case. All right, so the innovation is non-drastic, which means that the new equilibrium price approximately equals C0, technically equals C0 minus epsilon. And with that, we can come to to task D, the final task of this exercise, where we are asked to compare the results of all previous or of the previous tasks. So starting with the benchmark world, which we were looking at, and then continuing throughout the bear draw and competition market results for innovation and without innovation. All right, and one way to do so is by simply putting them all in a table. So in the first row, you see the profits that each firm gets in a symmetric world, so where there is no innovation and both firms have the same marginal costs. The second row then gives the profits of each firm, or the sum of profits of all firms in case we are in a asymmetric world, so where there is one firm that innovates. And then in the third row, you see the change in profits, all right? And what we can see is that actually in both scenarios, the Cournot as well as the bear draw oligopoly models, we see an increase in profits, which is kind of what we should expect given this whole exercise is called dynamic efficiency, which is all about decreasing costs in the long run and thereby increasing welfare not only consumer surplus, but also the profits. Then what we can see, of course, is that there is a difference between the market outcomes or the effect of this innovation between Kuno competition and Bertrand competition. And this is, we can see that in the case of Bertrand competition, the increase in profits is way larger, which of course is an immediate result from this corner solution that we get in the Bertrand competition, in this very simplistic version of the Bertrand competition, where we have zero profits in case we have two symmetric firms, and at the same time one firm gets to keep the whole profit margin between the new reduced marginal cost and the market price as soon as they innovate, right? Which is of course a rather extreme result.